Good day, good peoples. This video is on functions and its models. You can use this video for mathematical modeling and or college algebra. So if we could jump right into it, functions. A relation is any set of ordered pairs x and y, and all the x values in the ordered pairs together make up the domain. All the y values in the ordered pairs make up together the range. The domain is known as the input value or the independent variable, and the range is known as the output value or the dependent variable. As I kind of discussed in class, an input or a function is an input output machine. You put something in and you get something out. If we think about a vending machine, you take your money and you put it in the vending machine and then you get out the snack that you selected. The input is your money and the output is the snack that you select. Okay, but just remember that if you're dealing with a function, it's even in relations, every possible input leads to only exactly one output value. So for every one x value, there should be a y value. All right, so the output is the function of the input. So in other words, there are no x values that are going to be repeated. All right, so if we look at a couple of these comparisons that I have here, P is with M, Q is with N, R is with N. This is considered to be a function. Just as we discussed in class, the double standard of functions is the x's would be like the females and then the y's would be like the males. Double standards of the world is sometimes men can do some things that women supposedly can't do. But nevertheless, just keeping it on topic, the x values cannot repeat, but your y values can. Okay, if we look at our next example, we have a relation, another relation function, right? Where P is with x, Q is with y, R is with z. Every one value of x is with another value of y. The last one is the relation is not a function. Is if we take a look at it, we have P goes with X, Q goes with Y, Q goes with Z. Now, if we notice, this Q is starting to repeat because it goes not only with Q, Q not only goes with Y, but Q also goes with Z. All right. So that is an example of not a relation, or not a function. All right, so anytime your x values repeat, it is not going to be a function. All right, so if we take a look at our first example here, we have a graph of a different set of ordered pairs. So let's collect our ordered pairs and we'll just see what we have from left to right. So our first ordered pair here is a -5, and I can't see, -5, -7. All right. Our next ordered pair is going to be a -3, -2. Our next ordered pair is going to be a 0, -2. Our next ordered pair is going to be a 5, -7. These ordered pairs up here, this one will be a 1, a -1, and 6. And last but not least, a 3, 5. Now that we have all of our ordered pairs listed, do any x values repeat? There are no x values that are going to repeat here. All right, so then this would make this being a function. So this is a function. All right, so the next part of our question says for us to find the domain and range. So if you remember, I just said your domain is your input values, and your input values are going to be your x values, right? So if I'm looking at my x values, well, let's see what I have. I have -5, -3, 0, 5, -1, and 3. And then that will be my domain. Your domain are all of your x values. especially in a relation, which a relation is a set of ordered pairs. Okay, and again, here we have our range. Range are your y values. So if I'm looking at the y values, I have to take a look. Let's see what I have. I have -7, -7, oopsies, -2, 6, and 5. Now, notice I did not repeat my -7 value, right? And I did not repeat my -2 value for y. Just like we were talking about in sets, we do not repeat any sets, anything in our sets if they have the same number, right? Like when we have that union. Okay, you don't bring 2 couches to the new home. You just bring one. All right, the vertical line test. A set of points in a coordinate plane is the graph of a function if and, Miss Parker's bad writing, if and only if the non-vertical line intersects. I feel like it just did not. The graph in more than one point. Okay, so vertical line test is just simple. You draw an imaginary line through the graph, and if it intersects only one time, such as this one, then it is a function. However, if you draw the imaginary line through the graph and it crosses twice, such as this one, then it will be not a function. So again, if you draw an imaginary line through the graph, it intersects only one time, then it is a function. If it intersects more than one time, 2, 3, whatever, then it is not a function. Okay? Now, let's try a different approach. Let's determine if it is a function, and then we'll find the domain and range. So if I draw me an imaginary line straight through the middle, vertical line, how many times does it cross over? It only crosses over once right here. So the first part of the question is, yes, it is a function. Okay, that answer is yes. But my next part of the question is asking for the domain. So if I'm talking about the domain, I said the domain is all of your x values, right? All your x values. Well, this graph goes, your x-axis is here, right? This is your x-axis. You start to look at where does the graph start on the x value and where does it end on the x value. So if you have to remember, in domain, we are always going to read from left to right. Okay? So if we start here to the left, it starts at -3. Okay? And if we go all the way over for our x values, it stops at +3. Okay? So our domain is all of these numbers between -3 and +3. And that will be our domain. Please also notice that I use what? Brackets. The reason why I use brackets is because this ends with a closed circle. So that means we are going to include that number, right? So that is my domain. Now, to find the range of this function, we would do all of the y values, right? Now, when you're reading the y values, you're reading from, it's like a Drake song. You're starting from the bottom, and then you go to the top, okay? So where would we start, excuse me, tongue-tied, for our y values? So what is our lowest point on this graph? Our lowest point on this graph is this right here, right? So roughly, where does that cross for the y? For the y, this is 10, 15, 20, 25. So we could say roughly a negative what do you want to say? A -27. Okay? That will be for the y. That's our lowest point on the graph. Okay? Now we have to look at our highest point on the graph. If we look at this highest point on the graph, it may be a little bit below it. If we look at our highest point on the graph, then we could say it crosses at 40. Okay? So, again, if you're looking for the range, you're going from the bottom to the top. What is your lowest Y value? What is your highest Y value of that graph? If you're looking for the domain, you're going from left to right. What is your furthest left and furthest right value? Okay? Now, if we do one more quick example, since I'm limited on time for the video, the first question asks me to determine if it's a function. I'll draw a line straight through, and how many times does it cross? It crosses only once. So guess what? Yes, it is a function. Now, if we want to look at the domain and range, this one is slightly different. So if I'm looking at the domain, again, that's your X values. Your X values, you are reading from what? Left to right. So where does your graph start from the left-hand side? Well, if you notice, we have an arrow pointing. The arrow is obviously pointing to negative what? Infinity. Okay? So our graph to the left starts at negative infinity. Where does our graph end on the right? On the right, it ends at positive 4. So my domain is from negative infinity to 4. It starts here on the left. We don't know what number it is, so that's why we're saying negative infinity, and it stops at positive 4. Now, for our range, for the range, we are again going from the bottom to the top. Okay? So, range, if I'm looking at this, right? What is my lowest point on my Y? I mean, what's our lowest Y value? Well, the graph starts here, but remember, this is an ordered pair of 4, 0. So that Y value is going to start at what? 0, right? And now where is this Y value going? It's going to keep going up, but we don't know where it's going because as it goes up, it's going down with negative infinity. So it's going to, our Y value goes up, remember, going up. So where does Y go to when it's going up? It goes to positive infinity. So since this graph is still moving in a direction, the Y value of this will be positive infinity. Okay, so we've done it. You've done it graphically to figure out if it's a function. You have looked at a set of ordered pairs to determine if it's a function. And so the last thing to determine if it's a function is algebraically. Now, determine if the algebraic equation represents a function. Just remember, I just said every x value should be associated with a y value, right? So with that being said, is you always want to solve for y, okay? You want to get the y by itself if you're trying to determine if the algebraic equation is a function. So in this case, if we go ahead and take the square root of both sides. I know you may not know that, but y equals to the square root, the plus and minus square root, right, of 2x squared plus 3x minus 2. Okay? That means I am going to have two different inputs to get my output. Okay? Because I have a plus and a minus of that. So then this means that this is not a function. All right? Now, when I have y equals to x squared plus 3x minus 3, this is already solved for y. Anytime I plug in any number for x, I'm going to get one distinct value for y. So this is a function. Anytime I see this, I'll plug in any number. I can plug in 5. Any number that I plug in, I'll get what? One distinct value for y. So that means that is yes. Okay? So the way that I've remembered it is I can have a higher exponent of x. All right? You can have a higher exponent of x and be a function. All right? But you cannot have a higher exponent such as y squared and be a function. So anytime I see that y squared, I say, oh, it's not going to be a function. All right, but if I see an x squared, then yep, it's going to be a function. All right, got a little bit more time left for this video. So an application example, right? For the following, determine whether or not the relationship represents a function, explain your reasoning, and indicate the domain and range of the function. Okay, the PC industry celebrated its 35th anniversary in 2010. The U.S. sales of S personal computers in millions of dollars by year X are shown in the table. Is S a function of X? So if I look at this, in 1975, there was 0.04, 1980, 1985, 95, 2000, 2005, 2010, 2015. I can say that safely that this is a function. Every year is associated with a certain amount of sales. All right. Yes, this would be a function. Now, there are no years that repeat. It's quite obviously, but there's no years that repeat. So the X values are good and it's associated with a member of Y, which would be the sales. So then this will be yes, a function. Okay. So I do believe part 2 of that asks us to find the what? The domain and range. So obviously the domain would be the year and the range would be the sales. All right, moving forward, let's look at a graph. You definitely need to see this one. So if I look at this and we want to evaluate functions, all right, when you evaluate functions, you can do it graphically or you can do it algebraically. So if I want to evaluate this function, which is the figure shown of 2x cubed plus 5x squared minus 28x minus 15. Part A says use the points on the graph to find your values of f of -2 and f of 4. So if I want to find f of -2, this means now function y, a function in standard form, right? Just this general standard form is y equals to f of x. This is how you signify a function. All right, we'll go into more detail at another time, but y equals to f of x. That's how we signify that function. So if I'm looking for f of -2, that means my x value, right? F of -2, that means my x value is going to be -2. So on my graph, I come and figure out what my y value will be when x is -2. So what will be my y value when x is -2? So here's this point here. So roughly, I can say that my y value, I guess, is about, what do you say? 45, okay? Maybe 40, 42, okay? We may say 45. Let's try 45. 42, okay? So that gives us a rough estimate. My graph may be a little off, all right? Now, the next one says f of 4. So we want to find f of 4. That again means that we have our x value being 4, right? But we want to find our y value. What is that value when x is 4? What is our y value? So if I come up here, this is roughly about here. So we want to say that's about, I don't know, 70, right? So we can roughly say that's 70. Now, how can you really be sure, Ms. Parker, that that is the answer? So this is the reason why part B says it wants you to find it algebraically, right? So if you were to use the same thing to find it algebraically, if we use f of -2, wherever we see an x value, we will plug it in for our x value on f of x, meaning this should be 2 times -2 cubed. Oh, I don't have enough space. I'm not done, Zoe. It should be 2 times -2 cubed plus 5 times -2 squared minus 28 times -2 minus 15. So 2 times -2 cubed is going to give me a -8, and a -8 times 2 is going to give me a -16. Plus 5 times -2 squared is 4, and then 5 times 4 is 20, right? And then this should be plus, because -28 times 2 should be 56, right? Minus 15. So plus 56 minus 15. Okay? Make sure, yep, that looks about right. So now if we keep going and combine all of our like terms here, what do we get? So we will need to do -16 or 20 minus 16, however you want to put it, right? Plus 56 minus 15. And you end up with 45. So I actually was right the first time. I should have kept my 45. Okay? So 45 is really our answer. That is the exact answer. So when you're evaluating with an equation, again, the x is your x value, the f of x, right? Or the number inside of the parentheses is your x value, and you plug it into the equation. All right. I won't do f of 4, but it's pretty much the same gist. We would just do 2 times 4 cubed plus 5 times 4 squared minus 28 times 4 minus 15. And then hopefully that answer comes out close to what we have there. All right. So please read through your notes. Please try to do some of this on your own. And that concludes our video for today. Thank you.